Welcome. This lesson, we're going to talk about the creation of a new function called ArcSine. Okay. And after that, we're going to talk about the difference and what's the difference or the sameness of the between this notation and other notations about this function. So first of all, we want to create a function, right? So that function has to satisfy this definition, right? Which we're going to be creating a rule that assigns to each input, right? Whatever that input is, right? That input can be X, can be A, can be whatever. Input is just a placeholder. It's a placeholder. So we can just, we can just call it, anything you want to call it, right? Say we can call it triangle, right? So that's input is going to be triangle. So it produces an output. And for that input, the output is exactly one, unique, right? So you can use any symbol you want. So the point we're making here, in the function definition, right? Using X, Y is just, it's a habit, right? But X can be anything. It's just a placeholder. It holds a place. It holds a place. Now I'm just changing it to triangle. Okay, you can change any way you want to. Okay, you change anything any way you want to. As we study trigonometry, I wish to remind you that we're always on this stage set. So whenever we talk about trigonometry and those functions, we are on a stage set. And on this stage set, right, we have the standard position, we have the angle measurement, and we have the definition. And last time, we have been primarily discussing sine function. So this rule, right? We know that sine function, take the input of any angle, okay, any real number, which it will be taken as radians, produces exactly, so for each angle, it produces exactly one ratio, okay? And what we have studied about this function is that we have created this unit circle, we have created each one of these points, right, in the previous lessons. And the next one is that we take the arc length for each angles measured from standard position along with its sine ratio, which are the blue numbers, and we created the sine curve. So on this sine curve is a clear relation between input and the output, which is the y coordinates on the unit circle. Okay, so that's a direct relationship. What else have we studied? We studied domain and range. We studied domain and range, right? So this domain and range in one sentence for any input, right? We could just change it to triangle, right? Just a placeholder. And this placeholder can be any angle in degrees or radians or arc lengths, okay? It can be any way you want. And what else have we studied about this function, right? We studied whether this function is one-to-one, right? And obviously it does not pass the horizontal line test. It doesn't, right? If I draw a horizontal line, it crosses at so many points, right? More than one. Therefore, it is not one-to-one function. If it is not a one-to-one function, what does that tell us? What does that tell us? There's no inverse, right? So this sine function, as we know, does not have inverse. Does not have inverse. Okay? Now, it doesn't have inverse. Okay? So sine, so let's write it down, right? So these are the bullet points. Number one, sine function, as we know it, right? Sine x, sine whatever, is not one-to-one. Thus, it does not It does not have inverse. Does not have any inverse, okay? It does not have an inverse, whatever, however you say it, right? It doesn't have any. Number two, right? We studied one-to-one, so it's not one-to-one. And we have made the argument about it is not a one-to-one along the way in the previous videos, okay, in the previous lectures. And how about increasing, decreasing, right? We have discussed that too. You know, it increases on certain intervals, decreases on other intervals, right? So in terms of increasing, decreasing, because increasing, decreasing concept it's on specific intervals, right? So we have discussed, we have talked about it, right? Sine x, we can say sine x is increasing, it's increasing, wait, change the mode, right? Is increasing where? In which interval? We have to specify the interval, right? For example, we can say sine x is increasing from negative pi over 2, or in that interval to pi over 2. Okay, and we can also say, right? So that's one statement. We can make that statement. We can also say sine x is what? We can also say is decreasing. There's so many interval it decreases, right? From negative, right? From negative 3 pi over 2, right? Over here to right here, right? Negative pi over 2, right? We can say that too. Okay, and there's so many intervals you can make such a statement. You can also say from pi over 2 to 3 pi over 2, right? You can also say sine x is decreasing from pi over 2 to 3 pi over 2. 3 pi over 2, right? So all of these are the narratives we can put together to describe. And sometimes you will use open interval, okay? And sometimes we use this close. It depends, right? Depends on our need. In this case, you know, if it's true, then you're gonna say it. Then you can also use the open interval. Okay. Now, so it's a periodic, right? We also mentioned as a periodic. Every circle, right, from 0 to 2 pi, from 2 pi to 4 pi, right, from negative 2 pi to 0. We have done all of these graphing. Now, number 3, even odd. We have determined that sine function, okay, sine function is an odd function. Okay, sine is an odd function, right? We have demonstrated that. As an odd function, of course, we know that sine of, you know, the opposite input produces opposite output, right? So inputs, opposite. Outputs are opposite as well. Put a negative sign in front of one and we'll get the other, right? Or you can express it the other way, right? Sine x, right? There's another way of expressing this. Sine x is a negative of sine of negative x. How do we get that? We just simply multiply negative sign on both sides, right? So this is another way to express sine is an odd function, okay? These two cannot combine, okay? These two cannot combine, okay? If you know the order of operation, these two do not join, okay? It's just that the flow of this calculation goes like this, right? We have x as input, and then we're gonna produce negative x, right? And negative x, and then we're gonna apply the function, right? Sine of negative x. So produces sine of negative x. And afterwards, after we got the output, we put a negative sign, we found the opposite of it. Okay, this is the flow. Versus this guy, sine x is just, it's a different order. Okay, different order. And this is how it goes. X, just give it to sine, right? Sine x, okay, and produces sine x. So as an odd function, we just know that if you do it this way, the output, the final output is going to be the same as this one. Okay, graphically, what does that mean? What does that mean? We have talked about this meaning, right? So let's do it one more time to understand the odd function. Okay. Well, I was kind of anticipating there might be some questions, right? What does this whole thing means? What does this whole thing means, right? Sine x, right? The curve is like that. This is sine curve. Okay, I'm going to make some adjustment to demonstrate the meaning of this picture. Okay, all these negative signs here and there. You know, some negative sign is placed on, you know, some negative sign is placed on, you know, different things. You know, if you input some of the negative sign, you know, placed on negative outside, inside, what's the difference, right? So let's go through this again, okay, in this, you know, clean setting. So now, if this is x, right? So we're going to use the golden color because that reminds us of the arc length or the radiance, right? So now, excuse me, I'm choosing x arbitrarily. Okay, I'm choosing x arbitrarily. If this is x, right, its opposite is going to be on this side. Okay, so now I'm going to mark it. So this is x, and this side is going to be negative x. Okay, x and negative x. What will be the output? The output for sine is going to be the blue color, this guy. For the negative x, the output is going to be like that. So these two dots, okay, these 2 points, okay, I'm going to use heart and star. If you mark these 2 points, right, so let's put the notation in place. So this point, the input is x, the output is f of x. Okay, and the star, okay, this point is negative x as input, right? And its output is f of negative x. Okay, so this blue, okay, let me see if I can use a blue color. Okay, this blue color is f of x. And this other blue color, okay, this other blue color is f of negative x. All right, because the input is negative x, therefore, you see the point is marked that way. Okay, these notations, you must make sure you understand these notations. Okay, otherwise you're going to be awfully confused. Okay, now, since we're dealing with sine, therefore, I'm just going to replace f of x, right? So the definition, so now I'm going to kind of replace it by these symbols. Okay, so in our case, this is really, right? This is really x sine x, right? And this point Okay, this point is negative x sine of negative x. You guys see that? Okay, sorry, I actually missed a close parentheses here, okay? All right, let me just do it over. Okay. Do it over. Okay, so this point, which is negative x is the input, f of negative x as output. Okay, which these two are the same. These two are the same because f is just mention any odd function. Here, this is just sine, right? So these two are the same. And this guy, right? This guy, f of negative x, is really just sine of negative x equals to that. Okay, so these two are equal. And this one is just sine of x, right? So notation-wise, right? That's a notation. Okay, so now what have we cleared about sine x, right? Whoops. This is the sine x, right? Which is here. Sine of negative x, sine of negative x. You can see opposite input produces opposite output. Why? Because if I flip this over, right? If I put a negative sign in front of sine of negative x, what will happen? This blue will flip over. Okay, this blue will flip over. So the negative of sine of negative x, right? So if we flip over sine of negative x, flip over right here, flip over, so that is going to be negative of sine of negative x. Okay, which is right here. Okay, you can see now these two are the same. So that's what this expression trying to express. So this piece is expressing this process, okay? Sine of negative x, which is here, and flipped over, and these two are the same. Okay, so that's the explanation about this new form. I don't remember I gave you this before, and which is similar to that, okay, which is similar to that. But anyway, without further ado, so we have talked about even odd functions, and we know sine is odd function. And we done graph, right? Now we know sine has no inverse. Okay, so I'm gonna clear everything. Since sine has no inverse, but we want to create something we want to create a new function, okay? What do we do with this new function? What do we do with this new function, right? Sine function takes angle and produces ratio. Okay, sine function takes angle, produces ratio. So from angle to ratio. So we get a bunch of sine ratios, don't we? Or how many sine ratios do we have? Infinite, right? We just name a few. Right? The new function we wanted to do is that we want to go from sine ratio. Okay, we want new function to do sine ratio, from sine ratio as input, not Russian, sine ratio as input produces angle. And then it's going to produce angles. Produce angle. So each ratio produces one angle. Each ratio produces one angle, right? So I'm gonna bring this piece next to, I'm gonna bring this piece. It's gonna, we actually going to, you see, sine produces from angle to ratio. And ArcSine, we wanted to produce from ratio to angle, right? So we are under a lot of stress, but now we're going to have a name for this function. We're going to call it ArcSine. The ArcSine function. Okay, so the input is going to be ratio. Okay, the input is ratio. Input sine ratio. Right? We talk about the range of sine, right? So sine ratio can only be between -1 and +1. So sine ratio, so this ratio can only be from -1 to +1. Right? If you look at all the blue numbers, right, they're between -1 and 1. If you look at the picture, as we talked about earlier, right? I'm sorry, this, I'm going to use a different color, right? The angle can be any real number in both directions, right? Those are gold arc lengths, right? And the ratio is going to be between -1 and +1. So the highest one is +1, the lowest one is -1. So the horizontal span and the vertical span, right? Now, so if we work with the arc, the input for ArcSine can only be between -1 to +1 because it just reversed the relationship, right? So the output becomes input, but the angles, right? For example, the relationship is not 1-to-1, therefore we have to do something to make it 1-to-1, because we have to say, you know, for example, for the ratio, say ratio, right? Let's take an example, ratio, right? This ratio, we're gonna take 1/2. We're gonna take half for the ratio half, right? Ratio half certainly is in that interval, right? And this ArcSine is going to produce an angle. It's going to produce an angle. And which angle do you choose, right? Because there's so many angles that will give us the same ratio, right? Pi/6 is one, 5π/6, right? And if you go around, you get another one, right? If you keep going round and round and round, you get another one. So you have at least 2 output. We cannot allow that for function, can we? We cannot allow that for function, because for function, it has for each input, there's exactly 1 output. So some of the output has to go, right? So from the unit circle's perspective, we have to truncate, we have to cut off something, right? So now the ArcSine rule said we can only produce exactly 1, okay? We have exactly 1 or unique angle. So this angle has to be unique. So you either choose pi/6, 5π/6, or 5π/6, or many other angles you can turn around and round to get, right? Now, that mathematical community has decided, hey guys, if I choose only 1 angle, I'm going to choose the easiest one possible. Okay, I'm going to choose the easiest one possible. If you look at the unit circle, right? If we reverse the relationship, right? If for that ratio, we only want to get 1 angle and 1 angle only, and we decide, right? What are we going to decide? We decide we're going to chop off the entire half, the other half of the circle, which we just truncate it, drop it. Okay, and we only take this piece and that piece. Well, we cannot allow to go around and round. Okay, what does that happen? So the unique angle we require, right? We require that unique angle must be okay, in this interval between negative pi over 2 to pi over 2. Does that make sense? Does that make sense? And no flying over the no flight zone, okay? So when we handle ArcSine, you cannot go over pi over 2. You cannot go over negative pi over 2. So this piece is truncated. It's truncated. Okay? So with that said and done, okay, from the unit circle's perspective, right? We're not missing any number from the blue number, right? Because every number we have in blue on this half of this half circle, and we have them on the other side, and vice versa. So we just truncated. So we're not missing any possible input between -1 and +1, right? We merely limit our output to be exactly 1 by allowing only the angles between negative pi over 2, right, which we're going to measure clockwise, and these other angles from 0 to pi. So that is the rule for ArcSine. That is the rule for ArcSine. Okay, so now let's look at this relationship. Let's look at this relationship. Suppose, okay, suppose we're working with this piece, right? So now I'm going to get to the next page, right? And to go into the details about this process. Okay, I'm going to clean up, right? I'm going to clean up. Now we know the creation of ArcSine. This is what we want, right? This is what we want. Now, the creation of this function, okay, the creation of this function from the unit circle's perspective, right? We're going to come back to this piece, okay? We're going to come back to this piece later. So first we look at the unit circle perspective. We're going to look at the unit circle perspective. We want input, right? Exactly one angle has to be from over here, okay? Unique angle, okay? And in this case, of course, it's going to be pi over 6, pi over 6. So now we're going to systematically show you more examples about this creation. We're going to show you more examples about this creation. So let me see if I can, I'm going to make a table. Wait, maybe 3 columns, okay, for one. Oh, wait, I need more rows. Okay, I need more rows there. Okay, and I will need another row. Okay, knowing our process, right? Knowing our process. Okay, when we are creating this ArcSine function, right? So we need to look at the function we work with, right? For the sine function, we only going to be looking at angles, right? Angles between negative pi over 2 to pi over 2. We're not going to use 3 pi over 2. If you do 3 pi over 2, we cannot do 3 pi over 2, because to do 3 pi over 2, you're going to fly over. There's no flight zone. This is no flight zone, okay? This is no flight zone. Okay, no flight zone. You cannot fly there, dear, okay? No one can fly there, okay? No angle measurement can fly over there. Okay, you can only limit here. You either go from the standard position here or from the standard position there, okay? Got it? So this is the sign we're gonna limit it to. Okay, so this will be the angle. So what we do is that we're gonna review what we have done. What do we have done, right? So we're gonna go over from -1, all the blue numbers, -1. So what number give us -1, right? That's negative pi over 2. Negative pi over 2, okay? And sine negative pi over 2 produces -1, okay? So the inverse, I'm sorry, the input output, the input, okay, this is A, right? Let me be consistent, and sine A, sine of that angle. So this is the angle, this is the ratio, okay? Now, on the arcsine, we're gonna take the ratio, right? This is gonna be the ratio. Ratio will be the input, and the new function is called the arcsine. Arcsine, okay? So the ratio, we're gonna give a name, say, let's see, let's give it a name. Give it a name for, it's just a placeholder. So let's just use X, right? After all, X seems to be so popular, okay? And the output, right? The output will be ratio X. The input, I'm sorry, the input will be ratio X. The output is going to be arcsine of that number. Okay, so let's first set up. So now for this row, right, -1 become the input, and the arcsine one, I'm sorry, arcsine of -1, that input, okay, is going to be exactly the output. It's an input for sine. You guys see that? And this way we created this one-to-one correspondence. Okay, let me make the fonts just a little bit smaller so we have enough space. Okay, so now you can see the output, input output, -1, arcsine of -1 is -pi/2. -pi/2. You see that? Okay. Now, the next one. Whoops, there's a messed up, right? No fly zone. Okay, no fly zone. I'm going to redraw that because I don't want you guys to be confused, right? So this two quadrants are no fly zone, okay? Next, what is the next special angle? There's so many angles in between, right? They're also counted, right? And if you need them, you can use a calculator. The calculator will produce that for you. So we just go for the special angles. Okay, we will learn how to handle the non-special angles, okay? And which has been designed into the calculator. So the next blue number we have is -√3/2. So -√3/2 is really -pi/3, right? -pi/3. -pi/3 will be the input for the sine. Okay, so -pi/3. The output is -√3/2. Okay, we're gonna take this ratio as input for our arcsine. So our arcsine function take that input of ratio, produces exactly 1, which is going to be -pi/3. You guys see that relationship? It's like handpicked. This is the way we want it. This is the way we want it, okay? So for this ratio, it produces exactly 1 output, and that is the exactly 1. Okay, and next, okay, next, of course, is -pi/2, because it's -pi/2, right? I'm sorry, -pi/4, sorry. Okay, -pi/4. And sine of -pi/4, wait, sorry, -pi/4, okay, is going to produce, of course, it produces -√2/2. Okay, we all know that, right? We know that very well. So this is the, oh, sorry, what did I do? My bad. Okay, so I'm gonna make it up. Okay, so this is gonna be negative √3/2. I meant to put input output in that order. So this one is going to input is negative pi/2. Sorry about that. I want to be consistent, right? Now, so this is going to be negative pi/3. You can see that a process. You can see that process, right? By crossing out quadrant 2 and quadrant 3. So the next point is going to be negative pi/4, comma, negative √2/2. Okay. And for the other side, right, the input and output reverse. So this is how this one-to-one function is being created, and it's inverse created, right? And over here is ArcSine, right? And negative √2/2, it produces negative pi/4. Could it be other values? No. Definition of function dictates for each input, there's exactly one output. You cannot have more. Okay, if you give me more, you get 0 point. Okay, so the next point with this ratio produces this angle, which is unique. And we keep going. And the next one, of course, is going to be negative pi/6, right? Negative pi/6. So we go one by one, right? So all of these is going to be, so it's negative sine pi/6, right? And oops, geez. So this is 6, and this is pi, okay? And the output is negative half. Okay, now with that said and done, the input is negative pi/6. Negative pi/6. And the output is negative half. Negative half. And the reverse input becomes output, output becomes input. So this is going to be input is a negative half. And output arcsine of a negative half. Oops. Negative half is going to turn into, it's going to produce the output, right? The output is going to be negative pi/6. Negative pi/6. Okay. And there are lots of numbers in between. Okay. We're going to talk about using calculators to get them. Okay. So, but now you can see the special angles is serving us to understand this process. Okay. And your calculator has that function. So whenever you have a ratio that's not a special ratio, then it will produce an angle or degree as you wish, but they're going to be between negative pi/2 to pi/2 or negative 90 degree to positive 90 degrees. Okay, so keep going. We just have a few more to go, right? Among the ratio, it could be 0, right? Sine of 0 equals to 0, right? So it's this point, right? So we're going clockwise and we're going all the way there. So you know where we are heading, right? So this point is 0, 0. So when the ratio is 0, arcsine ratio 0 equals to 0 degree or 0 radian or 0 arc length, right? So 0 ratio, 0 angle. The next one is pi/6. Pi/6. Okay, so we have sine pi/6 equals to half. Okay, so in this position, in this place, right, it's pi/6. Pi/6. Oops, 5, 6, comma, half. Okay, and the next one, of course, the ratio becomes input for ArcSine, right? And the input is ratio, right? It produces an angle, and this angle is going to be pi over 6. Can we allow 5 pi over 6? Absolutely not. Absolutely not. Absolutely not. No way, Jose. Okay. So the next point on the ArcSine curve is going to be what? Is going to be ratio. Oh, sorry. Jeez. Ratio input and output is pi over 6. Pi over 6. Okay. And we have 1, 2, 3, 4. We have 4 more to go. Okay. So I'm going to insert 4 more rows. And 4 more rows. Right. And as we mentioned earlier, then these were the special angles or special ratios serving us for, right? So we can understand that process. Okay, so next one is pi over 4. Pi over 4. So sine pi over 4, which produces exactly one output, which is root 2 over 2, right? Which is root 2 over 2. And next, we're going to have the point, which is pi over 4, right? Comma, root 2 over 2. Okay, and when this is the ratio as the input, ArcSine of this ratio, okay, you can see that this is how we write it, right? How we write it, that's going to be pi over 4. Pi over 4. Academically, these are the possible questions you could be asked. Okay, for non-special cases, sometimes it show up, not very often, not very often. So input, output. So ArcSine just play that role. Okay, pi over 3. So we're so close, right? So next we're going to graph. So sine of pi over 3, we know what that value is. We are pretty familiar with this process. So this is going to be root 3 over 2. Okay, and that point is going to be input, output. Oops, my bad. Output. Okay, and that output becomes input for ArcSine. There, it produces pi over 3. Exactly one output. You see how the one-to-one function is guiding us going through these steps, right? So next, and that's input output. So this is really the, the input output at its practice, right? Wait, do we have pi over, oh, okay, the next one, the last one is pi over 2. Pi over 2. Okay, pi over 2, we have sine pi over 2, which is going to be, oh no, pi over 2, right? That's equals to 1. So 1 is going to be our input for this is oops, what am I doing? Sorry. Pi over 2, comma 1, right? So the ratio is input ArcSine of 1 is equals to pi over 2. Okay, you don't have to memorize this, but if you look at the unit circle, you already have the answer, right? Input is ratio, output is pi over 2. Okay, we actually did not need that many. That's it. That's it. So this piece, okay, so now we're going to plot these points. We're going to plot these points to see what's happening. What's happening, okay? So now we're going to plot these points, and you see the relationship. You see the relationship, right? We need to guarantee that 1-to-1. We need to guarantee that 1-to-1 from the unit circle's perspective. From the unit circle's perspective, okay? So now let's plot the points. Let's plot the points, okay? For sine function, okay, for sine function, okay, so we're gonna graph it. Okay, so we're gonna clean up the previous one. Obviously, wait, I don't think I want to do this. I don't think I want to do this, not yet. Okay, we're gonna just do the points. Okay, not yet, because we're doing this from the perspective of the unit circle. Okay, we're gonna do the other one later. Okay, okay, we're going to plot these points to see what happens, right? Because that's, we know that we can create this picture with our, you know, with whatever we need, right? So we're gonna put it here, the graph, okay? We're gonna plot the dots, okay? So this is going to be something like that. Okay, well, so I'm constructing the frame for the plotting of these points, okay? I'm gonna use different color. Sine, we've been using blue, right? So we're gonna use blue color. So these points will be plotted for the blue, okay? So I would like you to plot them with me, okay? So maybe you may like to take a picture, right? Because I'm gonna move to the next one. Okay? Maybe I will put it here. Let me do it here. Okay, so this table I'm going to copy and paste it right here so I can plot the points. Okay, so you can see, I can see as well. Okay, we know that this is the sine after we truncated the quadrant 2 and quadrant 3, right? Only quadrant 1 and quadrant 2. So what do we get? Right, so we're going to plot these items, right? We're going to add these items. Wait, so negative pi over 2, comma, negative 1. Okay, I'm going to use the blue dot. One point is plotted right here. The next point, so I'm going to do one by one. So blue dot, right? Blue dot, wait. Add a point, blue dot, add another point, which is negative pi over 4. So let me do it this way, negative pi over 4. And that's negative root 2 over 2, right? Add another point, negative pi over 6. And that's negative 1/2, right? And 0, 0. One more dot, pi over 6, and positive 1/2. Okay, we need to remove that negative sign. One more, so keep going, right? So that's going to be pi over 4, and this is going to be root 2 over 2, right? One more dot, pi over 3, that's root 3 over 2, and pi over 2, and pi over 2, and that's going to be positive 1. Okay, did I make any mistake? Oh, this is positive, this is negative. This is going to be positive, right? There we go. So I'm checking these points. I think we're good. This is the sine curve between negative pi over 2 to pi over 2, right? I'm not going to connect the dots yet. If I let the computer to connect the dots, they're going to give me the whole sine curve. Okay, they're going to give me the whole sine curve. So we're going to leave it like that. Just imagine that piece of sine curve between negative pi over 2 to pi over 2. And now we're going to graph its inverse. We're going to graph it the inverse from the same, in the same picture. Okay, in the same picture. And when we reverse these, right? So -1. So we're gonna have to choose a color, right? We're gonna have to choose a color. What color do we want? Certainly not blue, right? We're gonna make it, what color do we want? This color? No. How about just use black? How about use black, right? Use black. Where is it? Where's my last point? Where's that black point? Oh, I need to choose the dot, okay? So there we go. That's a black dot, okay? This is a -1 comma negative pi over 2. -1, negative pi over 2. Now, we're gonna keep going. Okay, we're gonna plot point by point, okay? Point by point. We choose a black dot, right? So that's going to be the black dot, a negative √3. That's the second point. And add another point. That's going to be -√2 over 2. Right? We need to make some changes, right? Negative pi over 4. And you are encouraged to do it with me. Okay. And that's -½ and negative pi over 6 and 0, 0, right? 0, 0. So next comes to the positive ones, right? Positive ones, pi over 4. Oops, 4. And the next one is going to be ½ pi over 6. Okay, last but not least is 1 pi over 2. So let's look at these black dots. Let's look at these black dots, right? It looks like, they are, that's how they're scattered, right? So let's mark them. Let's mark them, right? Let's mark them. So we're gonna mark them. We're gonna mark these points, okay? And this dot, this blue dot, right, is, I'm gonna use writing, okay? So this blue dot is on sine curve. So that's gonna be, I'll make it thinner, okay? So this is negative pi over 2, comma, -1. And this dot, okay, is in black, which is -1, negative pi over 2. Okay, so these two dots, these 2 points. On this side, okay, on the black is the inverse function, ArcSine. So I'm going to mark this point as, that's going to be 1, comma, pi over 2. And this blue dot, okay, my blue dot here is pi over 2, comma, 1. Okay, I would like you to try to mark all these other points. Okay, I'm going to continue to mark. And this black dot, okay, is on the arcsine. Therefore, it's the ratio of root 3 over 2, comma, pi over 3. Pi over 3. And this blue dot is going to be pi over 3. And the ratio is root 3 over 2. Okay, I hope that's clear. And these two dots, right? I think I'm going to wait for you guys to write it down. You know, pause it as you need it, right? So I'm going to continue to mark, but I need to clean it up because I need space to write it down. So we've done 1, 2, 3, 4, 5, 6. We've done 6 points, right? So I'm going to clean it up because you can always pause and come back to watch it. So next, I'm going to continue to mark, right? So this black dot is on the arcsine. Therefore, that point is root 2 over 2. And the output is pi over 4. Okay, and the blue is pi over 4. The input and the ratio is root 2 over 2. And next, right, we're going to do these 2 points, right? The blue is the sine, okay? So this piece is going to be negative pi over 3. And the output is negative root 3 over 2. Okay, so that's for this blue. The black, this one here is negative root 3 over 2, comma, negative pi over 3. Okay, so this marking, that's a blue, that's on the sine curve. The black is the arcsine curve. You can see the coordinates are just, remember when we try to find inverse, we have swapping, right? The swapping input with output. That's what happens here. Okay, so next I'm going to clean up. I'm going to mark the remaining points. Okay, so you can come back to watch it, right? They're there. And these two, the blue is on the sine curve, right? So I'm going to use the blue. That's the negative pi over 4. And the ratio, input is angle, the output ratio is negative root 2 over 2. Okay, that's for this blue term, blue point. And the black one on this side, this point is negative root 2 over 2. And this is going to be negative pi over 4. That's the output for arcsine. Okay, you see the visual, right? You see the visual. Now, you've seen this clearly. Now these two, right? These two, one black, one blue, one black, one blue. I know it's a little difficult to see, but we're gonna, and the black one is on the arcsine, right? The black one is on the arcsine. So we're gonna have the angle, which is root, is gonna be the black one. So that's gonna be the inverse, right? The half and the pi over 6. And the blue is on the sine, which is going to be pi over 6, half. They're still kind of a little crowded there, right? There we go. Well, you can separate these two pictures and see better for yourself, okay? So three more points to mark. The 0, 0, I'm not gonna mark it, you guys got it. So now this is a negative, right? The negative pi over 6, negative half, right? So one more time, okay? The blue dot is here, right? So the blue is gonna be the sign, which is negative pi over 6, right? And this one is going to be negative half. That's the ratio. Input is angle for sine or arc length. Output is ratio. The black dot is for arcsine. So the ratio is the input, which is a negative half for this particular point, and the output is negative pi over 6. You see, you should hear consistency, right? As my marking is not perfectly written, I wish I have better tool to do this. And writing with mouse is just not the best way to show you my best handwriting. But forgive me, I hope we have made it clear. I made it clear, okay? So next, we're gonna graph. We're gonna graph the black, okay? Now, graph the black. ArcSine X. Look at that. Look at those, the black dots. Do you see that? The black dots. So next, I'm gonna graph the blue. When I graph the blue, you're gonna see not only the blue dots are connected, you're gonna see the entire sine curve, okay? Why? Because no software actually graph this piece of sine. At least I haven't seen it. Okay, but you understand these two functions are inverse to each other. Okay, so before I graph the blue, you can see they are symmetrical. They're symmetrical about that green broken line. They're symmetrical. Okay, so now I'm going to graph sine finally. And we want it to be blue. Okay, so for the blue, really, I can manually make it happen, which is I'm going to do this. If I want to show it to you, right? The two perfect, symmetrical about the blue curve, right? And I can do something. Yes, I can. So I just need to erase that piece. So these two are the one-to-one functions that are inverse to each other. Okay, so let's mark these functions. The black one, of course, is just arcsine. Just arcsine, okay? You don't have to do anything, any function, any scientific apparatus who does arcsine, they would automatically do it for you. But the blue one, as a sine function, the description for this sine function is going to be sine x, okay, with negative pi over 2 less than equals to sine x. Oh, sorry. Do this. Okay, I'm going to do this. Pi over 2 bracket, where I can use a, right, to emphasize that a is in this interval. So this function, the blue function we have here, actually is different from the sine as we know it. Okay? In the future, whenever the sine function is mentioned, it's never meant to be this one, which as a result of truncation. It's always referred to the function we know as sine. So the function we know, sine and arcsine, they are not inverse to each other. Fortunately, okay, and unfortunately, this may confuse a lot of people, but we need to understand arcsine is not the inverse of sine, okay? Arcsine is the inverse of this sine, but this sign is rarely used. This sign is rarely used, okay? So what else we can talk about? Okay, so maybe we're going to talk about the other perspective, right? The other perspective is that we can look through another lens, another way of explanation, right? Which we're going to do just shortly, So this is the function that we're dealing with. Okay, so these two. Okay. So now summarize. Okay, summarize. So now we have 3 functions in our summary. We have 3 functions in our summary. Okay. We don't need so many rows. Sine function, right? Sine function, or A, whatever you call it, the input, right? ArcSine. Okay. So domain is all real numbers. All real numbers. Okay, we know everything about it so far. ArcSine's domain, this ratio, right? Domain is between -1 to +1. Range for sine, okay, is between -1 to +1. Okay, and of course we have other expressions of range for sine, right? Which is here, I'm going to give you all the options, right? Sine x, sine A, whatever you call it, since we use sine A, we have, this is less than equals to 1, right? Another way of expressing range is sine is between -1, A, less than equals to +1, okay? So these are the expression. Domain, right, for arcsine, we have other ways to express it, right? It could be x, right? This x is between -1 to +1, right? And the range and the domain can also be expressed as absolute value of x, which is less than equals to 1. So all of these are, in fact, these are preferred, and these are preferred, as we stated before. And the range for arcsine, okay, range for arcsine, we know that the range is between -π/2 to π/2, right? -π/2 to π/2. And we have other ways to express them. So I'm going to add some more rows. Okay, in case we need more, right? So range has all these different expressions. And the next one is arcsine is going to be between, right? -π/2 less than equals to +π/2. Okay, and the other expression for range for arcsine would be the absolute value, okay, for arcsine x, which is less than equals to π/2. Okay, there. So domain with all these different expressions, range, Okay, so I'm going to put the range together, right? So domain has all these different expressions, range for both functions. How about the other sign, right? The other sign with the constraint, right? With the constraint. I'm going to put it here. The other sign, which is the inverse for ArcSine, right? It has the same domain. No, has the same, the domain is from negative pi over 2 to pi over 2. Okay, as we have shown, right? Domain and range, right? Range, which is all these different ways, applies to it, right? All these different ways applies to it. Only thing is the domain is different. For this A is between negative pi over 2 to pi over 2. You can think of that way, right? So this sign of A, A is between these two numbers. Oops. We know all of these facts, okay? But unfortunately, this function is rarely used, which is also less than, wait. Oh, A, sorry. A is less than, the absolute value of A is less than or equals to pi over 2. Okay, for domain expression. Unfortunately, this piece, okay, okay, I would say is rarely used. So it's rarely used. It doesn't mean it's never been used. If it's been used, it will be indicated it's a special domain as needed in different places. Okay, you will see that in the future. Sometimes you use part of the sign from 0 to 2 pi, for example. So this will be specified as we use them. So most of the time in our language of speaking sines and cosine, sine function and arcsine, these rarely mentioned. Okay, so anytime we say sine, we refer to this sign. This is our star. Okay, anytime we say arcsine, we're talking about this arcsine. Okay, if you can forget about this guy. But we need to understand these two functions are not inverse to each other, right? Because from the graph, they're not, right? So now I'm going to give you the whole picture about this sign and this arcsine, okay? I hope you're ready. I hope you're ready. Okay, so now we've done this picture, so I'm going to use this picture. I'm just going to show, whoops. I'm just going to show you, right? The wider range. The wider range. So you can see in the popular community, right? So this is going to be, say, I'm going to make it a larger interval, right? Right, you can see this black one is arcsine, and the sine is, you know, from negative pi over pi over negative pi over 2 to pi over 2 on this piece, right, is considered as a part of the entire sine. And so in your study, you just have to know these two functions are not inverse to each other, okay? And only this box, okay, let me see if I can box it, right? Wait, okay, clean it up. I'm going to have to change the color because, okay, so now, okay, so only this piece, okay, only this piece. Only this piece wait, here. Only this piece we have, or this is not quite proportional, right? Because the 1 and 1 are not the same. So let me do it again, okay? So only this piece, whoops, come on, let me do it again, okay? You can see that I want these ones are proportional, so you can see better there, right? So these ones are, the ones horizontal and the vertical are proportional. So now, so I'm going to mark that piece, right? I'm going to mark that piece. So only this corner, okay, only this corner, right? You see these two are inverse to each other, but the blue, the entire blue piece is not the inverse of ArcSine. Only this piece, which we mentioned sine between negative pi over 2 to pi over 2 is the inverse of ArcSine. So that's what this picture means. Some people say, oh, when you talk about sine, which sine do you refer to? When we talk about sine, we always refer to the one that's defined on the entire number line, unless otherwise specified. It's always the case. If it is otherwise specified, your professor will say so. If she or he doesn't, it will always refer to the same blue, because the inverse for ArcSine is rarely used. Okay? And next, I'm going to speak about the notation. Okay, notation. What a notation. Wait, here, okay? Notation. Notation-wise, you see this notation, sine inverse. This seems to gain popularity in notation, in the world of notation. Okay, sine inverse. Okay. Well, people read it as sine inverse, but it's really a misunderstanding. It should be read as ArcSine. Okay, so this is referring to ArcSine. So they are the same. They're meant to be the same. So don't think of sine. This is the inverse for sine. It is not. It's ArcSine. It's the ArcSine. Okay, ArcSine means what? Means what? Yes, it means the domain. Okay, the domain is the absolute value, which is the in, it's less than or equals to 1, and the range is the same, okay, as is between negative pi over 2 to pi over 2. Okay, I wish you guys understand that. So this notation sometimes can be confusing. Okay, so this is less than or equals to pi over 2. So this way of writing sine inverse is the same as ArcSine. Okay, it should not be read as sine inverse, but people do that. Okay, even I do that sometimes. So just to clarify that, there are a lot of mistakes about sine inverse. Okay, there are not a lot of mistakes about sine inverse. For example, some people will say, hey, sine inverse, is that 1 over sine? The answer is no. No. Okay, not at all. Why? 1 over sine actually is cosecant, right? 1 over sine is a cosecant. And ArcSine has a domain, and domain and range even don't match, right? Because a cosecant, you just make sure the denominator is not 0. So it's entirely different. The input for sine inverse, right? Sine inverse or ArcSine, okay? So you see, I say sine inverse, right? ArcSine. I'm going to say ArcSine. So I want you guys to read ArcSine for sine for this way of writing. And I'm going to try to do that myself. Okay. So the input for this function, okay, either one, okay, these are ratio. These are ratio, okay, but it cannot be any ratio. It cannot be any ratio. And this ratio has to be where? Where has it to be? It has to be between -1 to +1. And the output are what? Are radians or arc lengths, okay? Radian or arc lengths on unit circle, okay? On unit circle. And where is it going to be? It's going to be between -pi/2 over pi, 2pi/2, you guys. Okay. How about 1/sine? What kind of input does this guy take? Okay. If you look at the flow, x is going to give it to sine, right? X is going to give it to sine. This is a very common mistake. Okay, it's a very common mistake. Okay, this give it to sine, right? What can be qualified for sine? Can be degree, can be radians, right? So this x can be anything other than whatever makes sine x equals 0 because it's in the denominator, right? So x cannot be multiples of pi. Okay, it cannot be multiples of pi. So in this, but x are angles, right? It produces what? It produces a ratio, right? It produces ratio. And that ratio is going to be what? And then once we get the sine, and we're going to leave it, we're going to do this, you know, reciprocal. We're going to do the reciprocal. We're going to take that ratio and we turn it upside down, right? Then we produce 1/sine. Okay? So sine x is a ratio. Do you guys follow me? It's very important to understand that. But very unfortunate, we see these mistakes at very high level courses in mathematics. We see these mistakes in calculus, calculus classes. I mean, calculus classes, I use plural, okay? Not just one calculus class, not Calc 1, we see you see that in Calc 2, and so on and so forth. So these, do not make these mistakes. Do not make these mistakes. Okay, I think I have addressed pretty much everything so far as I can recall. Okay, this piece of lesson is very, very important. Very, very important that you understand the inside out about it. Okay, so without further ado, I will, well, there's another perspective which people say, hey, the truncation of the sine curve, which produces the ArcSine. That's another perspective as well. Okay, so basically it's the same idea. It's the same idea. We just take the blue piece and produces the blue piece from -pi/2 to pi/2. That's 1-to-1. Therefore, it has inverse, and that's exactly what we did. It's just we use the unit circle as our guide. Okay. The next question. What if it is not a special angle? Right? What if it is not a special angle? What if it is not a special ratio? What do you do? Right? Suppose that we have a non-special ratio. Right? For the special ratio, we know what to do it. What if you have a non-special ratio? Right? So I'm going to take this piece. Okay. Let me make it just smaller so it's more manageable. Okay, so I'm going to take this piece, right? We know how to handle ArcSine now, and we know how to write them, right? We know how to write them. And then, wait. Now, for ArcSine, right? You have that button on your calculator, right? What if the input of ArcSine for ArcSine, okay, is not a special ratio? Well, if it's not a special ratio, the first thing the ArcSine will check is whether the input is going to be between -1 to +1, okay? Because that's a domain. If it's outside, say if you put an input of 2, right? ArcSine of 2. And your calculator will tell you it's undefined, or they tell you whatever way, right? There's no answer, right? And what if you put, you know, this -1? -1, yes, we have an answer. How about -1.5? Undefined, okay? So in both cases, it's undefined because you're outside the domain. It's outside the domain, so undefined. Second case, okay? Case 1, okay? Outside the domain of ArcSine. Yeah, that's the first case. ArcSine. Okay, if it's outside the domain of ArcSine, which is, what is the domain for ArcSine? We already know that, right? It's between -1 to +1. So the input has to be between +1 and -1, between -1 and +1, right? So this has to be strictly checked. So the scientific equipment is designed that way. And the next case, right? Case 2, right? The ratio is between. So we have an input ratio that is between -1 and +1. Whatever value, right? It is going to produce, okay? ArcSine predictably is going to produce an angle, produces an arc length or radian, which is going to be, you can expect that answer between -π/2 to π/2. That is the power of knowing the domain and the range. Okay, in particular, okay. Now, in the case, remember, you know, we show you the unit circle, right? I want to bring you that unit circle here. Okay, if your ratio are positive, okay, if the ratio is positive, okay, I'm going to put a little something here. Okay, if the ratio we get is between 0 to 1, right? Between 0 to 1, positive ratio, any positive numbers, okay? So you can play with that on your calculator. Okay, if it's between 0 and 1, you should expect ArcSine is give you an angle. It's going to give you an angle. That angle is going to be between 0 to π/2. Guaranteed. Okay. However, if the ratio you have, if the input you get is between -1 to 0, okay, then you should expect your ArcSine is going to produce an angle. Okay, you can safely expect your ArcSine is going to produce something between, it's going to be negative. It's going to be negative. Okay, it's going to be negative pi over 2 to 0. Okay, for obvious reason. So all the ratio between -1 and +1 are covered. Positive ratio, we get positive angle. Those angles will be measured counterclockwise. Negative ratio will get, negative angles that measured clockwise. Okay, but never ever, okay, never ever from on this side. Not even flying over them. Okay, no flight zone. No flight zone. I hope this is clear. And if you guys have any questions, please let me know. I'm looking forward to, to explain anything that you might be confused with. Okay. Thank you for watching.